Black holes, the ultimate destroyers. They devour stars, planets, and light itself. But here's the question, can black holes be destroyed? What if we tried everything: bombs, antimatter, even breaking the very laws of physics? What would happen if we took science to its extremes? Today, we're stepping into the lab of imagination. We'll build a tiny black hole the size of the moon, and then we'll try to destroy it. Are you ready to challenge the universe? Let's begin. If we want to destroy something, why not start with the most explosive tools we've got: nuclear bombs? Imagine detonating every bomb on Earth around this tiny black hole. A chain of fiery, glowing blasts lights up the void. And yet, nothing happens. You see, black holes don't care if it's energy or matter. Anything that crosses the event horizon, that invisible boundary of no return, just adds to its mass. The energy from the explosion? That just makes the black hole bigger. So nukes? Not even close. Let's move on. What if we hit it with antimatter? Matter and antimatter annihilate each other. What better way to destroy a black hole? So, let's take an antimatter moon and smash it into our black hole. Boom. And still nothing. Why? Because black holes don't care what you're made of: matter, antimatter, or a banana. Once something crosses the event horizon, its past identity is erased. All the black hole cares about is gravity, and gravity only depends on mass and energy. This simplicity is what makes black holes weird. In fact, they're kind of like elementary particles, such as electrons. You see, an electron can be described by 3 numbers: its mass, its spin, and its charge. That's it. And black holes? Exactly the same. No matter how it formed, whether from a star, antimatter, or a pineapple, it's just described by these 3 values. But what if we tried to make an anti-black hole? Would that work? Let's say we create a black hole with opposite charge, its anti-version. We crash it into our original black hole and they combine. The charges cancel out, and what's left? A bigger, neutral black hole. Not exactly the dramatic explosion we hoped for. Clearly, we need to think bigger, beyond nukes, antimatter, or anti-black holes. What if we broke the very rules that define a black hole? The event horizon is the black hole's prison wall. Cross it and you can never return. But what happens if we push a black hole to its limits? Here's the thing. Black holes can spin. They can also carry an electric charge. But there are limits to how much spin or charge they can have. Push either to its extreme, and something bizarre happens: the event horizon could disappear. Without the event horizon, the singularity, the core of infinite density, would be exposed. You'd still be crushed if you got too close, but you wouldn't be trapped forever. You could, theoretically, approach the singularity and escape. Would this count as destroying a black hole? Maybe. But is it possible? Let's push the limits. If we overload the black hole with spin or charge, we might be able to break it. Imagine a black hole spinning like a cosmic blender. If we keep feeding it just the right particles with just the right amount of spin or charge, we might push it past its limit. But here's the catch: black holes resist this. If we try to overfeed it with too many charged particles, it pushes back. The same happens with spin. When it reaches its limit, it just refuses to go faster. It's like the black hole is saying that's enough. However, some scientists think there might be a tiny loophole. If we add mass or charge precisely before the black hole hits its limit, we might be able to tip it over the edge. Could this work? Maybe, maybe not. Here's where things get wild. If we destroy the event horizon, we expose something terrifying: a naked singularity. A singularity is where gravity becomes so intense that the fabric of space and time breaks. Normally, the event horizon hides this chaos. But if we remove the event horizon, the singularity would be right there, for everyone to see. What would that look like? We have no idea. Imagine a place where time doesn't exist, where and when lose all meaning. Logic breaks down. Cause and effect become meaningless. Out of this chaos, anything could happen. A planet could appear, or a galaxy, or even your missing socks. It's like staring into the universe's deepest secret and realizing the rules we live by no longer apply. This is why physicists believe nature prevents naked singularities. The universe, it seems, has safeguards to protect itself from total chaos. So, can we destroy a black hole? Technically, yes, but not by force. Black holes emit tiny particles over time, a process called Hawking radiation. Slowly, they lose mass, evaporating bit by bit until they disappear completely. The catch? This process is incredibly slow. A black hole as small as a dust particle would take longer to evaporate than the entire age of the universe, many, many times over. Black holes are often seen as villains, devourers of stars, creators of cosmic chaos. But maybe they're the universe's unsung heroes. By hiding singularities behind event horizons, they protect the universe from the madness that lies within. So, should we destroy a black hole? Probably not. Instead, let's marvel at them. Because while they may be simple in form, they hold the answers to some of the universe's greatest mysteries. The universe is filled with wonders waiting to be explored. Black holes are just the beginning. So the next time you look up at the night sky, remember, there's more to discover than we can possibly imagine. Are you ready for the next cosmic adventure? Let me know what you think, and don't forget to keep looking up. Stay curious. Bye-bye.